Okay, when you've written it this form, the solution makes a pattern. There's always going to be a constant vector here, right? And this vector here is defined by, if I set the free variables to 0, if I set y and w to 0, then I get out what's called the particular solution. Okay, but and this, it's going to turn out that then this other piece here actually will solve the original system if I set the 5 and the 12 to 0. That's called, with any system here, there's a homogeneous system. This is the homogeneous system. It's going to turn out that this is going to be a solution. So this is, and there's always going to be, the number of vectors here will always be the number of free variables. So it's going to turn out there's a pattern to the solutions for any linear system that follows this pattern. The slogan is particular plus homogeneous. So any solution is the form of particular vector plus the homogeneous one. In fact, you could actually see that because I have, okay. If I set in this equation y and w, the free variables, to 0, which is possible, then I get a simpler equation. I get x plus 3z equals 5 and 6z equals 12. So I can then say, well, I know that y and w are 0, and then z equals 2, of course, but then I can put in here an x equals -1. Well, that gives me one solution, -1, 2, 0, 0, which is this particular -1, 0, 2, 2, if I get the right, if I order them correctly. So you can find a solution to this system by just setting the free variables to 0. And then you could, instead of solving the whole system, you're going to be able to set this to 0 and this to 0 and solve the homogeneous system, and you'll get this piece here. And if you add those two, you'll get the whole solution. So anyway, there's just some patterns here, and we're going to want to look at those patterns. And that's the subject of chapter 2, but we're still in chapter 1 with linear systems. And so I just wanted to, we're just sort of feeling our way along here at this point. Let's do some more examples. Hopefully you've read this section, and we'll read this section about with planes and higher, sort of like seeing flat spaces intersect, and some of the regex questions involved with that. And then here's the general definition of a linear system. Well, it seems complicated, and it looks hard. It looks hard to look at because you've got, it is trying to be very general. So you have variables, but you're using subscript instead of x, y, z. You're using subscripts x1, x2, x3, x4, x5 up to xn. And here's your linear combination, where the a's are the coefficients, and then here's a linear equation where you take the linear combination here of any number of variables and set it equals to a constant. Now, the reason for making this general pattern here is because we'd like it sometimes to make claims about any linear system, so we have to let it be arbitrary number of variables, and that just makes it hard to look at. And then it helps if you know that, well, the letters near the beginning of the alphabet are all going to be constants, and the variables are going to be x's, and so then you see this, and then here's this thing with variables. You say, well, this equation might not be true, but if I choose, there's another one of these words, tuple, that comes from multiple. It's like just a sequence of values. So here's a sequence of values, S1, S2 up to Sn. So if I put in S1 for X1, S2 for X2, Sn S3 for X3 and Sn for Xn, if I make those choices, this is a solution if this is a true equation. So these are the choices I can make. So this sets up the idea of a linear system where now I have to have names for all the different things. I see the second here, X1, there's a 1, X1, 2, X2, and Xn D1. So this first row is our linear equation. And in the first index here, 1, 2, I have M equations. So this sort of is a way of giving names to all the coefficients and all the variables in a linear system. So this is the whole thing, and you can see that it's the solution. If I put the S1, S2, S3, Sn in for the X1, X2, Xn, it has to make all of the equations true. Now it's going to turn out that you see these numbers, A1, see the first one labels the row, and the second one labels the column. When we come in chapter 3 to matrices, we're going to end up with these numbers being in our matrix without the X's. We're just going to be looking at these numbers in a matrix, an array of numbers. And so this notation will reappear. So it's helpful to see that it really is connected to the linear system. And I know it's hard to look at because it's like, it's too chaotic. There's too much detail going on and you're used to looking at simpler things. Okay. So then we go back and some of the things we've talked about, and we want to come to some problems now and have you solve some more linear systems after all these examples. You look at these examples to the extent that you need, that you want to know. You can you could use these as exercises where you have the solution, where you know this. You could start from this linear system and try to reduce it to echelon form and see if you get the same thing that they do, just to practice. Okay, so let's try the hard one. Let's try F. What I want you to do, this is on page 53. Wait, let me get down. Yeah. Page 53, problem 19, item F is 4 variables, 4 equations, okay? Well, I want you to use Gauss's method to solve this system and write the solution as a set of vectors. So this is going through, and now there's 2 ways to do this. One is you can do a lot of writing on paper, or you could try to do it in licks, where that would cut down on the amount of writing you'd have to do, but then you have to know a little bit about how to set things up in licks. And I can maybe this may take a while. But if you try this, then I think this is the best practice you can do. If you can get through this and solve it, then you'll be practicing. And then after that, if you want, I think the best thing to do after we do this one problem, then I'll show you the answer and how I would write it up. And then maybe we could start working on wherever you are in assignment 1, so that you can get started on that, maybe in class, rather than waiting until Sunday or something. Because it's due this Sunday, assignment 1. And if you get stuck or you have a problem that you're not sure, if you're not sure, then you can always try to share your screen, and we can look at I can show you what to do next.